Welcome to video tutorials for SILCS Bio. In this video, we will go over how to identify binding sites with SILCS-Hotspots calculations using the graphical user interface. For this tutorial, you will need your directory with SILCS frag maps for the target that you should have generated using the SILCS simulations module. Additionally, you'll need a database of fragments or ligand molecules in STF file format that you'll be using for calculating the hotspots with. The information discussed in this video is also available on our documentation website docs.silksbio.com. You can go to Silks small molecule suite, then go to Silks hotspots, then go to SILCS-Hotspots using the SILCS Bio GUI. Let's start a new SILCS-Hotspots project. Hope you have generated the SILCS frag maps for your target. If not, you will have to get those using the SILCS simulations module before moving forward. Now we'll go to the SILCS Hotspot section and click on New SILCS Hotspots project. Next, we come to the setup page. Here we need to provide some inputs or choose some settings as we did for SILCS simulations. First, we need to give a project name. Second, we have our default remote server selected, auto selected. We can change if we want from the drop down menu. Next, we provide the SILCS frag maps directory location. Navigate to your directory and just click on the directory icon without entering the directory and click open. This will automatically select the protein PDB file for you as well. Then we have the option to choose the input file of our fragment molecules to be used for hotspots calculation. By default, the selection is provided with the rings in drugs database. Additionally, there is an option to choose the Aztecs minifrags database. Both of these databases are used in our validation studies before. You can choose the first option if you have an STF file with a customized database of fragments or ligands. Here we will choose a subset of rings in drugs database for this example. There are no advanced settings in this case, and we can click setup button. The command execution window comes up and we can see that a remote project directory is created. Then input files are first copied to a local project directory and then uploaded to the remote project directory. When that is complete, we can click the green button Setup Successful. Next, we can submit the SILCS Hotspots jobs and track the progress. On the next page, we can see a summary screen with the project name, remote server, project location, protein PDB file, ligand STF file, and the number of ligands. You'll also see sampling mode and bundle under advanced settings. There is exhaustive sampling mode available for large ligands, and the bundle option allows us to reduce the number of jobs in the queue by combining the individual ligand jobs. Here I'm going to increase it to 16. Let's click the Run SILCS Hotspots button now. The job submission scripts will get generated first, and now they are getting submitted. This can take a few minutes depending on the number of fragments and size of your target. We are going to fast forward it here to the last set of jobs. Once finished, we can click the green button saying setup successful. We can monitor the job progress here on the next page. Depending on the availability of compute nodes on your remote server, the jobs will start running and finish. Now the SILCS MC docking jobs running underneath using GPU are very fast, and hence the SILCS hotspots also takes only a few minutes per fragment or per ligand. Database of larger ligands will definitely take longer than the default databases. Next, we process and collect the hotspots data. Let's continue to our project with the Continue SILCS-Hotspots project option on the home screen. As you can see, the jobs are finished and a green show chart button has appeared. We can click that button now. Clicking the show chart button will start processing the results. If you encounter an error in this step, it is likely that required Python 3 packages have not been installed. Please refer to Python 3 requirement on the documentation website for more information. For each molecule, all docked poses will be collected. Any poses 6 angstrom away from the protein are ignored. Then an average LGFE for the bulk pose is calculated, and any poses that are less favorable than bulk are also ignored. Then a two-pass clustering is performed on the rest of the poses. We then get a set of clusters for every molecule in our database. Finally, a report folder will be generated and downloaded from the server. The GUI will automatically update once all the necessary data is generated and downloaded. Click on the data collection finished to proceed. Now let's visualize the hotspots results and analyze sites. This brings us to the Analyze page where we can see the protein and frag maps loaded to the stage, and a new tab labeled Table will have been created in the right hand panel. The Table tab lists the average LGFE and LE scores of each hotspot, referred to as site. By clicking on the ligand under the Table tab, we can center the visualization window at the ligand. Let's click on the box next to site number to display all the hotspot sites in the visualization window. Clicking the Save Result button on the top right will save the SILCS hotspots results for all the selected hotspot sites to our local computer. We can sort the table using the Sort Site By drop-down menu. One can additionally display only those sites meeting a cutoff criterion by using the Filter Sites By drop-down menu and adjusting the cutoff value. Let's clean our view a little bit so we can see the filtered hotspots. To measure the distance between two hotspots, select their solid spheres and click the measure button in the right hand panel. This will display a dashed line in the visualization window with a measured distance in angstrom from one hotspot site to other. Now in the chart tab on the right hand panel, converts the information from the table tab into plots. The plots can be adjusted similarly by sorting and filtering menu. The plot is interactive, and hovering your mouse over a point will display the X and Y values for that point. Now let's see how the downloaded files look like for our hotspots project. To access the downloaded project files, we can start on the home screen and go to Continue SILCS-Hotspots project button. Go to our project and click on the Show Project directory on the right. This will open the default file browser for the directory. Here we can see the report directory with a hotspot sites.pdb file. This PDB file has all the hotspots represented as dummy atoms. One can also load these results in other visualization tools such as VMD and PyMol. There is also a detailed report of each pose in a CSV file, and all poses collected by the ligand and by site in two other subdirectories. Alright, thanks for watching the tutorial. See you next time.